Hello everyone, my name is Ashfaq Ahmed and I work in the field of structural biology and bioinformatics. Today is the second video of the course Computer Aided Drug Designing or Skill-Based Computer Aided Drug Designing. If you have watched part first, then I assume you have your dataset downloaded into your computer. In this part, we will perform some further filtration, or we will learn how to perform some further filtration on that data, and we will also perform some preliminary analysis. And the third thing, we will learn how to filter this data and on what grounds, what variables, or I would say what feature we should look for or we should avoid. So before wasting much more time, let's start. Now we will connect to the repository. Get project, and here we will select part 2. Connect. Okay, once again, this part 2 is about compound filtration based on ADME and lead likeness. Today you will also learn the exact purpose of ADME and lead likeness. This first section is about introduction, so I don't need to repeat. Aims and objective of this repository is, once you finished, you will be able to perform compound filtration based on Lipinski rule, or I would say based on oral bioactivity of compounds. So first of all, there is some basic concept. It was not included in my first part but will be included after on, because I mentioned in part first that my mode of delivery will be a kind of teaching also. So first you should know about the basic concept. What is ADME? It stands for absorption, distribution, metabolism and excretion. Okay, about the absorption, about the ADME, you can read here that what does these four sentences or these four words means, absorption. So frankly speaking, once a patient takes a drug, it should be absorbable. If a drug is not absorbed well, then it is of no use. Suppose the drug is absorbed. What is next? It should be distributable. It should not stay in one place. It should be distributable into different parts of the body, or it should be absorbed in the bloodstream. It means this. The third step, it should be metabolized. Once it performs its function, then we don't want this drug to stay inside the body. Therefore, it should be metabolized, or it should be broken down into pieces. Once it is broken down into pieces or metabolized, then it should be able to excrete from the excretory system. If it stays inside the body, it may make some troubles. So that's why more often you heard a term that this particular drug is not good for kidneys and blah blah blah. So actually that means that it poses problem to the excretory system. Anyway, we are not going to that discussion, but I recommend you to at least read these sections a bit carefully, that for absorption what factors are important. For example, I would suggest two factors are important. We call it solubility, and then the solubility itself is managed by a value, we call it log P. Solubility in octane and solubility in water. If the solubility in water is higher, it means the drug is hydrophilic. If the solubility in octane is higher, it means the drug is hydrophobic. The same way, you need to read about the distribution and metabolism. I have mentioned all these things in sufficient detail. The second thing we will talk about is lead likeness and Lipinski rule. What are Lipinski rules? People mostly know it, rule of 5, and sometime from my student just abruptly I ask a question that, okay, how many rules are the Lipinski rules contains, how many rules exactly? And most of them answer me that, sir, 5 rules. No, this is wrong. Lipinski rules contain 4 rules. But why it is called rule of 5? Because all the values present in Lipinski rules are multiple of 5. So that's why we call it rule of 5. It doesn't mean there are 5 rules. Okay, so what are Lipinski rules, or what are rule of 5? There was a scientist, Christopher Lipinski, and he studied too many compounds, and finally he designed some rules, and these 4 rules, and he said that it should be present in good drugs. Or if I would say like this, if these 4 rules are satisfied for a compound, then it means it's a lead molecule. It has a higher druggability for this compound. But we will also discuss later on, we will know later on that it is not hard and fast rules. There are some FDA molecules that they are not following all these 4 rules. So this is not hard and fast, to be frank, but for a good initiation, as a good initiator, it's better to take care for these rules, and we can avoid later on if we feel we need to avoid some. So these 4 rules contains the molecular weight. It should be smaller or equal to 500 Dalton. Number of hydrogen acceptor should be smaller or equal to 10. Hydrogen donor should be smaller or equal to 5, and log P, octane water coefficient, I discussed a little earlier, should be smaller or equal to 5. Okay, so the third thing we will discuss about the radar chart in the context of lead likeness in this notebook. What is a radar chart? So radar chart is simply a kind of chart or a kind of figure which looks like a radar signals, and on the beauty of that chart is that we can study all the 4 Lipinski rules in one figure. So that is very interesting chart. We will see and we will calculate in this section. That is why it is also called a radar chart. Okay, so This radar chart is also called Greg's plot, flower plot, golden triangle, whatever you can say. You can read about more in this paper if you want. And I told you what the radar chart do, so I hope you will understand the meaning of radar chart now. So let's install RDKit. We will not install the Campbell clients we installed in previous section because we will not use Campbell or chmbl. Okay, now we will do some import operation. Import it. Okay, we will not use our data directly. First I will train you on 4 different molecules. This is for teaching purposes, so you will understand why I'm not using the data directly, because the data is huge. So first we will train ourselves on 4 molecules or 4 compounds, and we'll do some preliminary analysis to understand the concept of these 3 things we discussed above. Then we will incorporate, or we will load our data generated from part 1 and will perform the analysis. So it will be easier for you to understand your data then. So I have 4 smileys, and these are the names of these structures. So I ran it. Now I ran this cell, and this what I did, I just incorporated the smileys with the structures. So these are actually these 4 structures. We will work with it initially. So first of all, we will calculate the properties for these 4 molecules, or I would say the Lipinski rule for these 4 molecules. So right now we have calculated 4 properties: molecular weight, hydrogen bond acceptor, donor, and log P. Preview. So we just merged those properties with these 4 molecules quickly. You can see in the data frame. Now Ro5 stands for Lipinski rule of 5. We will run these cells. You will understand why we are running these cells. Okay, we calculated the properties for the 4 compounds, and if you have your own compound, you can put here and you can just calculate their properties, and then we plot it. So 4 figures, it means 4 properties: molecular weight in Dalton, HBA and HBD, and log P. So the color mentions their specific molecules. Now these border lines are actually the threshold lines, like hydrogen bond acceptor were 10 or not more than 10. So if you see the cyclosporine, it deviates the hydrogen bond acceptor, and it gives almost 11 or maybe 12. Also it deviates in the molecular weight area, but it's good here in the donor, hydrogen bond donor, and in the log P. So this way you can read this figure. Now we are interested to calculate what are the molecules that violates the rule of 5. We already know because 4 molecules, but it's just better for your understanding, for your own data analysis. It says that rule of 5 fulfilled for the cyclosporine, no, false, because I showed you in the figure it deviates 2 rules, and for clozapine and cannabidiol. Yes, they both said yes, they are following the rule of 5. According to the rule of 5, this and this are estimated to have poor bioavailability, because it is believed that those compounds which are following the rule of 5 can be administered orally, and they will behave better in the system for ADME. So, but however, since all of them are approved drugs, this is interesting. All of them are approved drugs, and this is actually a good example that sometime or in some cases how the rule of 5 are deviated. So from here now on, you should not strictly take the rule of 5, or don't fight with your colleagues that no, this drug is not following the rule of 5, so it should not be considered. It's okay, you can consider if you think it's a better drug in other properties. So we will discover much more properties down the road, so stay and be patient. Okay, now we are coming to some real business, and we will upload our own data which was prepared in our last section. So how to upload our data? Let me check the data. It is present in the download folder, so I will rename it because I don't want this extra one. Okay, oh my god. Okay, compound 1, maybe this will be okay. Now come here, come here, upload, and upload this data. Then once this circle is finished, it means the upload is complete. Now click here, this is your data. Click here, copy path, and in this section cleanly paste your data and run it. You will see your data prepared in part 1. If you have not run the part 1, so I am sorry, you will not have this kind of data, so you need to watch and run the part 1. Now we will calculate the rule of 5 for all the molecules present in this data set. If you remember, the data set contains 6,800 and I think 15 molecules. So for all it, the rule of 5 were calculated. Now we will merge, or we will concatenate the rule of 5 data with our data set. Now you can see Kimball ID, IC, nanometer, and those things, and now these things are merged with our data. So interestingly, what we found that we have total compound 6815, yes, compound in filtered data set 5430, compounds not compliant with Ro5 1385. What does it mean? It means in the 6815 compounds, 1385 did not follow the rule of 5. So we want to remove it, or if you don't want to remove it, that is up to you, because here I included both codes for you. This code, if you run this code, it will download the complete dataset, Ro5 properties, and it will come here. Let me refresh here. So this dataset, if you download it, interestingly, it will show you all the data. You can see this compound false, it means it is deviating. Yeah, here it is deviating 11. So this dataset contains all the data, but this one you will need to change these names in your project if you want to. The name is rule of 5 properties filtered. So this dataset only contains 5430 compounds. I removed those which are not following the rule of 5. Now we are going to visualize Ro5 analysis on radar plot. Here we have generated two data sets. What we did here, we analyzed the whole data on Ro5 on radar plot for Ro5, because I told you what radar plot do. It actually plots the analysis of rule of 5 or Lipinski rule in one chart. So here we perform calculations on the whole data, 6000 and something. Then we generated two data frames. One name was molecules Ro5 filtered, and in another case this name molecules Ro5 violated. So this will contain only those 1300 something, and this will contain the 5000 something. Why we generate it separately? Because we will plot them in the next step. But the Ro5 plot is a strange kind of plot, you will see. So that's why we need some steps, or we need some preparation on x-axis and y-axis. In fact, it do not has that kind of x and y-axis. This is a circular plot. So for that we will run these cells. You can read these x value preparation and y value preparation. Okay, now here we will generate two radar plots, one for filtered data which satisfy the Ro5 and vice versa, another one for the other data. This one is for filtered data. You can see this is called the radar plot. So this side is for HBA, this side is for molecular weight in Dalton, and this is for log P, and this is for HBD, hydrogen bond donor, and this is acceptor. The blue area, this blue, shaded blue, I would say this is blue, I think, so light blue I would say. This light blue area actually are the boundaries for designed by Lipinski, okay, and the dark blue, this line is the boundary for mean. This line, this one, These are the standard deviation, and this is the rule of 5 area. This one, sorry. Okay, now you will understand when we generate the second plot. Okay, now compare these two. This is, we know that this is the plot for the data which violates. Now you can see where the log p came. The rule of 5 area is almost here. This is the mean area, this is the rule of 5 area. Okay, and even it crosses here. I mean the log p reaches here. So even the molecular weight, it reaches here, too much high. It means the HBA is almost, I would say, not too much deviating, but and the HBD, it seems fine. Okay, now you see here almost all the things are near to this mean, the light blue. So this was the calculations for or some filtration. This is the interpretation or the description I already discussed for you. Okay, and here in the interpretation I made this area bold, like to see where the violation happened. Okay, now we had two more data sets. We had generated two more data sets. In part first we generated our data, and in part second we also learned how to filter this data, and we will continue this filtration, and we split our data set into two parts. One is the filtered data, which obeys or which follows the rule of 5. On the other hand, the second one do not follow or it violates the rule of 5. So we should have these two data, Ro5 properties. The whole data already I have downloaded, and this is the filtered data. Okay, so the data is stored, and in this lesson we have learned how we can calculate the rule of 5 or this kind of analysis. Remember, if you do not have this kind of data, for example you have 10 structures or 20 structures, you want to perform these analysis, so that's simple. Just copy and paste those smileys, and from where you will take these smileys, if you have watched my other videos, simply you can take these smileys from Pumpkin. Let me show you quickly again if you are new to my videos. For example, this is Pumpkin. For example, I type Ro5. This is your compound, or let's say any compound. So this is the smiley. So copy from here and paste it here or somewhere else, but do not disturb these I would say colon or double dash. Okay, paste it here. So you can perform such kind of calculation. Also paste their names in the sequential order. Of course it will waste some of your time, but if you don't have the data like we have from part 1, so you have to prepare your data manually, and that's it. I hope you will like this video and stay connected. I will try my best to bring some useful stuff, and we will also complete this course hopefully within this month or before that. So stay tuned, stay connected, and subscribe this channel if you are liking my videos, and stay happy. Bye bye.